So the first thing we want to take a look at is how to utilize the .forAll syntax within the contracts library. The .forAll allows me to assert the condition of a collection and make sure that every element in the collection is true. What we want to do is we want to go into our time machine class and add some logic that says when I ask for a list of all clocked in employees, that you actually return me that valid list. To utilize the ForAll, in our scenario here, because I'm doing a return, I need to utilize the contract.ensures. Contract.ensures, if you remember, will tell you that, or do a performance check to say that upon exit of this method, ensure that the state is true. So we're going to use that. Then I'm going to go ahead and do .forAll. ForAll is a syntax that allows me to check a collection. And because I'm using the ensures and with the result, I want to go ahead and say contract.result. And it's of type iList with clocked in information. Go ahead and put our final bracket down here. And then, I need to provide a generic. So I'm going to say where x.clockedOutState equals clockedOutState unknown. I basically am going to say that because I want a list of all my employees which are clocked out, let's go ahead and make sure that they are truly clocked out. So let's go ahead and put a breakpoint here. Let's go ahead and run my application and run it till we get to this breakpoint. I'll put one down here too just so we can show it working. So I've hit my first breakpoint and I have 3 items in my list. And if I go down to all of them, they all have clocked out state of unknown. So I should pass just fine. And sure enough, I have no exceptions, which tells me, hey, everything worked out well. To show you how to get this to fail, let's go ahead and comment out the logic that ensures that we're actually performing, getting only clocked in employees. Let's run this again. So I've hit my breakpoint again. This time in my list I have 4 items, and if I look at my 4th item, you'll see my clocked out state is an accepted state. And if I run this to my contract again, hit F10, you'll see that now I have an exception thrown, and my exception tells me my post condition failed. So I'm able to utilize the .forAll syntax to verify that every element in my collection must be in the clocked in state. So that's pretty easy and pretty straightforward. How do we go about using the exist syntax, where the exist syntax basically says at least one element in my list must meet this requirement. So I'm going to go ahead and use the same basic syntax as before, but instead of doing that ForAll, I'm going to use exist. I'm going to provide my contract.result, because again I'm doing this on the exit of a method. And again, I'm going to provide that my clocked out state is set as accepted. And here I'm basically going to say that at least one item must be in my accepted state. I'm going to go ahead and leave this check, this logic commented out, because I want to make sure at least one element is as accepted. So let's run this bad boy again. And so I've hit my breakpoint. I have 4 items in my list, and the last item is in the accepted state, so I should be good to go. So I was able to pass and I had no violations. If I come back to my time machine, I turn that code back on and rerun it, I should now have a violation because at least one of my items in my list will not be in the accepted state. So I've hit my breakpoint again, this time back to 3. And when I run over my contract, you'll see I do get an exception that tells me my post condition failed. So that's how you can utilize the collection verification within the contracts library, by using that ForAll and .exist. To use the .assert and .assume, we basically want to do very similar to the .require syntax. So I want to come down here. I want to say .assert. And I'm just going to provide my statement, my condition. And I'm going to say that my clocked in employees is not equal to null. And clocked in employees is a list up here that is pre-populated or pre-initialized upon construction of the class. So this should never not be null, but I want to add an insert process to verify that. And if I put a breakpoint here and run my code again, Okay, I've hit my breakpoint. And you'll see I'm not null, so I should pass just fine, and sure enough I do. And I'm going to hit this over and over again, so let's go ahead and stop that. To prove that assert will actually fail, let's go up here. Let's turn off the initialization. Let's rerun this. So I've hit my breakpoint again. Now when I F11 over it, I get an exception immediately, and the exception will tell me my assertion failed. So I can show that my assertion logic did actually provide value and did actually prove that something was null. And to do the assume, it's the exact same syntax with one slight difference. Instead of assert, I use assume. And I'm going to do clocked in state not equal to null. And if I put a breakpoint here and run that, I should get the exact same result. And I've hit my breakpoint again. I'm null. I fail. I get my exception. Tells me that an assumption failed. And all is right in the world. My code actually did exactly what I intended it to do. So that is how you utilize the .forAll and .exists syntax to assert the state of list or arrays, as well as how you can assert fact in your code at runtime by utilizing the assert and the assume methodology or methods. So I hope you learned something, and until next time.